Dr. Mariam. My name is Syed. Assalamualaikum, Dr. Mariam. My name is Syed HAIREL AZMAN and my matric number is 222532. And today I'll be presenting my group's project titled AI-based lab code detection control system with real-time Telegram notifications. As for introduction, this project aims to improve laboratory safety using AI-based lab code detection. And the system of this project use a camera and AI model to detect whether a user is wearing a lab coat before entering the lab. If a lab coat is detected, access will be granted. If not, the door will remain locked until the user wear a proper lab coat. The system combines AI, computer vision, Raspberry Pi camera module and door lock control. So this is the problem statements and objectives. So as for problem statements, first, manual monitoring of lab code compliance is inefficient and unreliable. Second, laboratory users or management may forget to check whether a proper safety attire is being worn. And third, entering a lab code without a lab and entering laboratory without a lab coat increases exposure to hazardous substances and the risk of injury. There is no real-time notification when someone enters the laboratory. And then as for our objectives, the objective of the project is to develop a camera-based AI detection that identifies whether students are wearing lab coats and then to improve laboratory safety by granting access only when the lab coat is detected. Then thirdly, to integrate IoT and embedded systems for real-time monitoring and access control. Lastly, to send a real-time Telegram notification after successful detection. Right, here is the system architecture of our project. First, it goes to user and then camera, AI detection, to check whether lab code is detected or not. If lab code is detected, the door will unlock and Telegram notification will be sent. If lab code is not detected, the door will remain locked and no Telegram notifications. Alright, this is our system workflow. First, the user stand near the system, and then system will perform liveness detection where the user have to move their body, and camera will capture the user's image. AI model will analyze and detects whether a laboratory code is worn. If a lab code is detected, the LCD screen will display access is granted, and the door will unlock, and then Telegram notification will be sent. If no lab code is detected, access will be denied, door will remain locked and there is no message being sent. So this is the circuit design where we use Arduino Uno, and servo motor represents the door opening and closing, and then the red LED light is to indicate whether the lab code is detected, and lab code detected when the button up there is bit push. This is the Alright, so now I'm going to discuss the communication engineering concept based on our project. So in the first row, based on the coding, bot token act as a unique token to identify the Telegram bot and allows the program to communicate with Telegram. And then chat ID act as the destination address of the receiver where the notification will be sent, and then Telegram send act as a flag that prevents the same notification from being sent multiple times or repeatedly. Then the next row, based on the coding on the right, on the left, YOLO performs detecting people in the camera image, and then it classify whether a lab code is present or not, and then it provides a real-time detection results. The camera will continuously captures images, and YOLO will process each frame before passing the detection result. Alright, so the notification is sent using the function of send Telegram message and the Telegram bot API URL, which is the communication endpoint between the Raspberry Pi and the Telegram bot API. Chat ID specifies the destination where the message will be delivered. Text contains the notification generated by the program. And then lastly, this function sends an HTTP post request to the Telegram bot API, which communication path is as below. So as you can see, Raspberry Pi, and then it goes to Wi-Fi or Ethernet, and then internet, and then lastly to the Telegram server. And then now the try block attempts to send Telegram message. If the message is sent successfully, if an error occurs, the accept block catches the error instead of stopping the program. And the next row of the table, these checks confirm a lag code has been detected and prevents the same alert from being sent more than once. Alright, so the system records the detection time and creates a notification. And then lastly, the message will be sent to the Telegram. So this is the flowchart of the concept, the communication engineering concept that I just explained just now. So first we start with start, and then you go to the camera, and then the camera will capture image, and then YOLO AI model will do object detection to detect the lab code, and then if the person has lab code on, and it will detect person with lab code, and then generate detection message with time and status, and then it will encode the message, chat ID and text, and then HTTP post request, which is request post, and then it goes to Wi-Fi or Ethernet, and then internet, and then Telegram bot API server, and then verify the bot token and chat ID, and then the message will be forwarded, and then the message will be received at the user's smartphone, and and then end. Now I want to discuss the impact of our project. First, we will go through impact. First, it improves which prevent wear tree without wearing the required lab coat, and this will reduce the risk of chemical exposure, contamination, and laboratory accidents. And then the next impact is provide immediate feedback. Users instantly receive an access granted or access denied response through the system. The automated decision will eliminate uncertainty and encourages compliance with the safety rules. Now, as for the impact for community, first impact is create a safer laboratory environment where students, lecturers, researchers, and laboratory staff will benefit from the consistent enforcement of laboratory safety regulations. And then the next impact is reduces human error, where students, lecturers, researchers, and laboratory staff will benefit from the consistent enforcement of laboratory safety regulations. And lastly, it improves communication between users and laboratory management, where Telegram notification provide immediate updates whenever access is granted. Laboratory personnel can monitor entry activities remotely without being physically present. Now I want to discuss the impact to our country. First, it supports the digital transformation and which encourages the adoption of AI, IoT, and smart automation technologies in educational institutions, and then supports Malaysia transition toward smart campuses and Industry 4.0 initiative. And then the second impact is it improves national laboratory safety standards, provides a scalable solution that can be implemented in universities, research laboratories, hospitals, and industrial laboratories, and it helps to standardize the PPE compliance across different institutions. So, in conclusion, we successfully designed an AI-powered laboratory access control system that integrates with communication network, and then the system integrates YOLO AI, Raspberry Pi embedded system, and wireless communication to automate laboratory access control. And then through the Telegram bot API, detection results are transmitted over the internet, enabling real-time remote monitoring and instant notifications. This project shows the practical integration of AI recognition, embedded systems, and communication engineering to improve laboratory safety, operational efficiency, and smart laboratory management. Alright, that's all from me. Thank you.